In this problem, a gold coin is immersed in water. What is the buoyant force experienced by the coin? So buoyant force is always equivalent to the weight of the fluid that's being displaced. Well, the weight of the fluid would be the density of that fluid times the volume of the fluid that's being displaced. But this coin is completely submerged. So the volume of the object, the volume of the coin, is equivalent to the volume of the fluid. And then times the acceleration due to gravity. So this, again, this is really the mass of the fluid that's being displaced times g. And this buoyant force then equals the weight of the fluid that is displaced. All right, so with this coin, we're given its mass and we're given the density of the gold. Well, density is mass over volume. And so let's say we're talking about our object here. Then the volume of the object, the volume of the coin, will be its mass divided by its density. And so rather than solve for that number, I'm going to substitute this in for the volume of the object so that we can say the buoyant force is still the density of the fluid, but times the volume, which is the mass of the gold, divided by the density of the gold, and then times g. So the density of the fluid, we have our water is 1,000 kilograms per cubic meter, times our gold coin, 0.32 kilograms, divided by its density, 19,300 kilograms per cubic meter, times 9.8 meters per second squared. So these kilograms per cubic meter are going to cancel out. We're solving for buoyant force. We got kilograms times meters per second squared. That is a Newton. So 1,000 times 0.32 divided by 19,300 times 9.8. I think I missed, yeah, I did. Right there, I accidentally did 100. So I multiplied by another 10 to make it 1,000. That's my fault for making a typo. Okay, but a force of 0.16 newtons.